This is our Fluid Dynamics course project. My name is Joshua Buttrick.
And I'm Matt Doyle.
Our project was to design a water supply system for a lakeside cottage and hotel. The first part of this project was identifying the water usage for the cottage. We assumed a family of 4 would be living in this cottage full time and have the appliances listed below. The first one was a toilet, which averages about 20 gallons per person per day, which makes up 80 gallons per day. The washing machine, which would end up being about 15 to 25 gallons per day, depending on how often the family runs a wash cycle. The shower, which would be about 80 gallons per day. Again, this depends on how often or how long of showers the family would take, but we estimate an average of about 80 gallons per day between all 4 family members. The indoor faucets, which would also be providing drinking water, and as such is 50 gallons per day, and an outdoor hose, which we would estimate averages out to about 15 gallons per day. This totals to about 240 to 250 gallons per day.
And now taking a look at our schematic, there are 5 major components here. So first, if we take a look at the water tank, you can clearly see that it is above the cottage, and then you can also see that we have 4 filters. So there's the inlet filter that is down at the bottom, which is right before the pump. And then we have a UV and carbon filter that is right before the water tank. And then there is also filters that will be placed inside the cottage themselves for drinking water. And then you can see that the pump is outside of the water, sucking water in to the pump itself. And then the piping runs 2,485 feet from the pump up to the water tank, back down to the cottage. And this is the water pump that we chose to use. It has a max height of 675 feet. Its flow rate is 8.75 gallons per minute. And in our calculations, we used 5 gallons per minute, which is 300 gallons per hour. And that if we go back to looking at our water usage table real quick, you can see that the total usage of the 4 people in the house per day is 240 to 250 gallons a day. And so 300 gallons per hour would mean that the pump only has to be run 1 hour per day. And that is where our expected cost of running comes from, which would be $4.14 per month of electricity.
All right, so our water tank, we chose a 2,500 gallon low profile cistern water tank. The total dimensions are 59 inches by 99 inches by 51 inches. The main feature of this is that it will be placed, again, 151 feet above the cabin. The purpose of this is that it will naturally generate water pressure for the cabin, so we do not need an additional pump to provide that. The 151 feet was achieved by assuming a optimal pressure of 65 psi within the cottage and was back calculated. The purpose of having a water tank is such that the system can call water without having to turn the pump on, and the pump only needs to turn on when the system gets to about 75% of its total capacity. The next system is the water heater. The water heater that we have chosen is an inline water heater, and as such can heat water on demand as it is needed. This water heater specifically can heat 11 gallons per minute, which we believe to be more than will ever be used within the cottage. This is a propane or natural gas water heater, and the expected cost of running based on the cost of natural gas is roughly $18 a month.
And looking at the piping, so like I had said, and you could see in the schematic, all the piping will be buried, and that is to prevent the water from freezing. So this piping material is HDPE, which is temperature resistant thermoplastic. And so in the winter, there will be no freezing. There shouldn't be any problems to that extent. And the diameter of the pipe is 1 inch, and you can see how that works out and is supported in our calculations, which I'll be talking about shortly. So next we move on to the water filters. So 4 types of water filters for the system. We had the UV and the carbon filter, which are placed directly before the tank. the inlet filter, which is placed at the in the suction pipe, which sucks water, clean water, hopefully, into the pump itself. It prevents any debris getting into the pump, possibly damaging the pump. And then we have the reverse osmosis filters that will be placed under each faucet to provide clean drinking water for the residents. And now let's take a look at the major calculations. And so we initially calculated that the tank height would be 151 feet above the cottage to supply sufficient pressure to the cottage on demand. And we also calculated the pressure difference between the pump and the tank. And so the tank sits at roughly 451 feet above the pump itself, and so the pressure difference we calculated was 195.6 psi, and the piping we chose is graded 200 psi, and so the max pressure here, the pressure would not affect the pipes, so there would be no bursting when the water gets pumped through it. And like we mentioned before, and as you can see in the schematic, the total pipe length was 2,485 feet. And if you look on the right here, you can see that the head loss we calculated was 42.67 feet. And if you compare that to the pump head of 451 feet, you can see that the max head of the pump, which is 675 feet, is plenty for the pump to overcome this loss. And the pump itself, its power usage is 431 watts.
So, as with any plumbing or any system in general, there is going to need to be maintenance, as parts will wear out, filters will need to be replaced, and here are some of the considerations that have to go along with that. So, as just mentioned, the filters will need to be replaced. They have a certain amount of water that they can filter before they are no longer usable, and as such, when these filters reach this limit, the actual filter portion will need to be replaced. This is the major point that we expect maintenance to need to occur on. However, other parts of the system can be damaged as well. But as previously mentioned, all of the components are buried, such as the water tank and the pipes, and this means that they will need to be dug up if any maintenance is needed on these systems. While this will incur an increased cost of maintenance, we believe that having the components buried will reduce the amount of maintenance needed and reduce the cost overall. The water pump itself will, as previously mentioned, not be buried, but rather be enclosed in a structure, and it will need to be inspected regularly, as it is a mechanical component that will be running once a day. However, if the pump shuts down or maintenance is needed, the water tank is capable of holding enough water for the cabin to survive 5 to 10 days, depending on the water usage of the residents. And finally, for the hotel expansion, the majority of the components that we have selected can remain the same with the increased water need of the hotel. For example, if we increase the number of pumps selected to 5 and increase the amount of time it is running per day, the pumps will be more than sufficient to supply the hotel. However, some components do need to change. For example, the water tank will need to increase its capacity to a total of 100,000 gallons, and as such, we have selected 5 20,000-gallon tanks to accommodate this. Additionally, the piping will increase to a diameter of 2 inches. All other components, however, will be able to remain the same, simply with increased quantities. Thank you.
Thank you.